so exciting for our commercial producers whom we serve that they're in a marketplace that's expanding and there's a vast appetite for more pork. And we're the people who provide this unique and leading genetic breeding stock to them to start that whole cycle. It's exciting to be in a growing global business, and we're step one in the chain.
All right, as everybody comes back in, we want to get up and going again. And we're going to talk about efficiency of the sow herd now. Shift gears a little bit. Problems and progress is improving sow herd efficiency. And with that, we got Mark Schwartz, Director of Production Systems at Schwartz Farms in Sleepy Eye. And he's basically a family pig and grain production company and responsible for the direction of both the production and the health of maintenance from the sow farm all the way through finishing. On his free time, Mark enjoys spending time with his wife Anita and his 4 daughters. And so the next speaker, Mark, you want to come on up and share with us your thoughts about sow herd improving sow herd efficiency.
Thank you. Good morning, and thank you for this opportunity to be with you today to share some thoughts and ideas on a topic that's very dear to me and one that I'm passionate about. And today what we're going to do is, what I'm going to talk about is 2 different aspects of this idea of improving sow herd efficiency from both the micro viewpoint and the macro of the on-farm details of management, one of the areas that's very important, I believe, and then more of a broader view from an industry, how do we improve the health status of our breeding herds. And so this is really a compilation of 2 or 3 presentations I've done in the last 2 months, and it was a week ago right now. I was doing much of this in Spanish, so it's kind of relaxing to be speaking to you today in English. So, sow herd efficiency. You've got the physics definition, right, of this ratio of energy used relative to what's produced in the form of work. And another physics or engineering type definition of the ratio of useful work performed by a machine or in a process relative to total energy expended or heat taken in. For this topic of efficiency, when we use the word efficiency and productivity, I believe, somewhat interchangeably, but it's doing something, making something, producing something without wasting, I can't say without, but minimizing waste of material, time, energy, okay? So it's being efficient. So on the sow farm, we have lots of different measures of productivity as we do in nursery grow finish, but this measure of efficiency, so if you look at it from the input of energy, really is pretty simple when you think about it. I think society loves complexity at times, but we have inputs in the form of energy in feed grains, right? We feed the sow, and she produces milk to feed the piglets to produce a wean pig to move on to the next phase of production. We use LP or natural gas to heat the barn and electricity to cool the barn. Those are our inputs of energy. Water, I suppose, from a cellular level would be energy. And then we have our human capital, as Steve mentioned, the people who do the work, do the job, and then our physical capital, or in economics would call it physical plant, the buildings we build to do that. So there's a mix of high capital, lower labor, to low capital, higher labor that we've heard about for generations, this mix. And so you have the systems, you can have the facilities as most of the pigs in the US are raised in. And one of my daughters last summer raised 3 pigs at her grandma's farm with a very low capital, kind of high labor for her, not a lot. But in that system, and raising pigs in that model. Those pigs, just as a point of interest, from wean to finish, did a 2.13 gain. So there's advantages to that. Then there's output. We raise pigs, wean pigs, market pigs, pork, and there's the other output of plant nutrients or manure. And there's really a simple process. It's how we get it done or implement it that at times becomes complex. So there have been major improvements in efficiency as far as energy input with genetic improvement and climate control to improve feed conversion and litter size and average daily gain. But 2 of the really big drivers, I believe, is feed conversion. This is just I pulled about 4 years of quarterly data, overall many closeouts, the continuous improvement in conversion, and the continuous increase in pigs born, live born per litter. So we've leveraged that. We've improved our efficiency with AI, right? With getting the best genetics to produce the leanest pig at the best conversion. Thinking about this in preparation, when you think about just the change in AI from having 1 boar for 20 sows 30-some years ago to 1 to 200 now with PC AI, taking that ratio further yet, my rough math, if 90% of the sows in the US are AI, probably close to 6 million bushels of corn annually is saved. So you talk about efficiency drivers. And think about that over 20, 30 years. Unfortunately, there's other aspects in production, as Steve mentioned, and some of you may think we all collaborated on those presentations, but we didn't. But other aspects of production that we're losing efficiency because of having to produce more gilts to maintain our sow inventories. So we measure efficiency at the sow farm level in pigs per sow per year. Okay, that's a measure of productivity, how many pigs we produce, and the number of pigs produced annually. The problem with that I have is there's no reference to wean age. One thing Randy Stacker told me a few years ago, Randy said, you know, in the pig business, we know the cost of everything and the value of nothing. And that's very true. And I've been on a soapbox on that in the last several years within our company. We have these measures of average daily gain, feed conversion ratio, pounds per square foot of building. Average daily gain is fine, it's average. It's no better, if the slowest pigs are very poor gain, we still have a drag on our system, so variation is important. So those are things that we use to measure efficiency. I pulled some data here from one of our farms from January 05 to this past summer in semesters, so every 6 months. This farm went from a 10 and a half, 11 born live to 15.6 in the last semester. So we're having 5 more pigs born live per litter. It's great potential to improve our efficiency and our productivity. This is number weaned on that same farm. And so weaning barely 10 to weaning 12, 12 and a half. We hit 13 this past semester on this farm. You see the gyrations and the variation, and those are the health events, which I'll talk on a bit later. So those are measures of efficiency. This is a bunch of farms from just in the last 6 years, 2015 to present by quarter. This is wean per litter, just over 10, and as a system, hitting 12 and a half wean per litter. So those are good numbers. The problem is the efforts and what we've done put into that to try to achieve that, and still the potential that's there, I believe, that's unmet. And so the idea of managing large litters, this increase in litter size, this unintended consequence of increasing litter size and variation and trying to manage them. Life was pretty easy when we had 12 pigs or 11 and 14 teats. We didn't do a lot, and we had single-digit pre-wean mortality. And so when you have 14, 15, 16, 70%, And people that don't see pigs and go in barns say, what are you guys doing wrong? That's the problem we have. So we've done all these things in our system and others, and I think they're good overall, but we focused starting, I think in 2013 on day one pig care with extended hours and overnight. That's good. We dry each pig, okay, not wasting time. I can't find a single study, including the one just done recently here, where drying pigs reduce prewean mortality. We got the heat lamp on already, we're paying for that, and we're drying pigs. Now, is it a bad practice for some pigs? Probably not. So we do hot boxing and split suckling. Those processes get mixed up at times by the caretakers, and you'll see pigs that are up nursing, probably the best place it should be, can be, getting warmth and nutrients, and it's pulled off and put into a hot box to warm up. So we do these things, we create complexity. We ask caretakers to do a teat count and write that on the card, and then go to a functional teat count, and then look at historical wean numbers to decide how many pigs to foster onto that sow, to use parity as a consideration, load all gilts to teat count to maximize that output, right? And then load parity 6 and older to less than teat count, and then size by litter and size by parity. But then a supervisor comes in and says, hey, you guys are moving too many pigs. And it's an area that I focus on, and I get under some skin of some people at times, because that's just day one. Then you go to post day one, and the bump weaning, the fallback pig management, leaving an empty farrowing crate, or a certain number per 48, is it 2 or 3, to move sows in to take on fallback pigs, to use wean sows for that process, to use fresh sows for that process. And the whole process becomes so complex. And if you really want to frustrate employees, is have a couple different supervisors come through and say this in different ways. It might be the same intent, but say it differently. And then tell them the next week they come back that they should have moved a pig or not moved pigs. And I make a point of every year, at least 1 week, going and working day one for 5 straight days. And can I meet the numbers that we say the employees should be meeting? And I can't. And I told that. I said, when you go in to a farm, to a supervisor, and you do that for a week, what numbers do you achieve? Well, I've never done it. Okay, don't be telling people to achieve a number if you don't know it's achievable. So that's really an area for me that's important as leaders of farms, like Steve mentioned. This is the problem. As managers, supervisors, we talk and think in terms of averages. This farm averages 14.5 born live. This is 2 different days on a farm of 16.1 on 21 litters and 13.5 on 40 litters a different day. Looked at a different day on a farm for 60 consecutive days. This is the average born live on each of those days. So my question is to the supervisors and those coming to the farms, how are you going to teach a caretaker to follow the rules of fostering when this is the reality of what they see day to day as the number? How do you manage for them? How do they manage their day one foster care? So it's become this complex area. And really, in our system, yeah, we've reduced stillbirths with extended care, and it's still, I believe, the right thing to do for the sow to be there. But we really haven't impacted our prewean mortality. So something that's not the intent of this topic, I thought I'd mention it. Again, we started in farms of 50 sows or 100 and maybe 20 farrowing crates, now asking caretakers to adjust heat lamps on 800 crates daily. Creep mat location, they get soiled, the sow moves them, and we're managing that. So we have 1 lamp, we have 1 mat, we have the comfort zone. So something in our system we're using on a farm successfully. My goal is to see, can I replicate it? Can I duplicate those on other farms? We've gone to a system where it's simple. Let the sow take care of taking care of the pigs, and the farm staff loves it. The farm is at 9.5% prewean mortality on a 26-day wean age. Another topic, Steve. With weaning 13.1. And this is what it looks like if it opens, or Stacy. Oh, there we go. So just a brief video of these pigs are, some of you here were in this room the day that we took this. About 25 days to be weaned in a couple days from now, 48 crate rooms, 17-pound wean weight. Pigs are born as soon as we possibly can when the 2 litters adjacent to each other are eligible, having received colostrum, teeth clipped, and iron. Open the front and side panels and get them away from the sow. So we're increasing space. We're able to creep feed 24 litters with about 4 to 6 feed bowls. And we have multiple lamps, multiple creep areas, multiple comfort zones. And it's really fun to watch. Pigs just go nurse wherever they want to nurse. And we do make a section of smaller pigs for 6 to 8 in a group of, so still 100 pigs are the smallest pigs right at birth. And it's been working well. My goal is to see if we can duplicate this on other farms. So shifting gears from the micro management viewpoint of challenges and problems with increasing productivity or efficiency is this macro view of health maintenance. And we've put a lot of dollars as an industry into increasing our biosecurity to attempt to reduce the incidence of PRRS primarily in our breeding herds. So we filtered farms. In the last 10 years, we're 11 years filtered on our first farms. We still have FERS breaks. I have a rule that if there's large finishing sites less than a mile from a sow farm, it's extremely difficult for those filters to be effective in reducing the viral load to a point that is still not a major risk factor. So we've done that. We've increased our truck wash. We've baked trucks. We've dedicated trailers. We've done all kinds of things coming into the farm at the sow farm level. And we've reduced PRRS breaks on a number of farms. They're still very disappointing, obviously, when you've gone through that process and still have a PRRS break. So the processes we've put in place, I believe, are good. The problem is where we produce our pigs. And my brother John mentioned this in a meeting here a few weeks ago, and it's very true. When we did the SWOT analysis, strength, weakness, opportunity, threat, often we'll say our strength is our geographic location. We raise pigs right where the feed is. The corn is cheapest probably in southern Minnesota and southeast South Dakota. The markets are there. You've got multiple processors within 80 miles of most of our pigs. And at the same time, we say our weakness is our location. We raise pigs where everybody else is raising pigs. And in this area, and I'll explain that in a bit, a map I produced, but it's the disease pressure that we deal with. And Tobler's first law of geography is that everything's related to everything else, but things closer together are more related than there are things further away. It's very true, in my opinion, when it comes to pig health and pig disease. So we understand well with Bob Morrison's Swine Health Monitoring Project, now 09, so we got 12 years of data, the incidence of PRRS breaks at the sow farm level. What I find discouraging is that you take this 11, 12 year out of there, it's an outlier apparently, maybe, but 22 to 35 or 30% of our farms break any given year in this data set. So we know that, we get that. But, and these farms are located primarily in areas where we want to raise pigs. This is 2017 USDA Agriculture Census of Ag, so it'll be updated next year. Where's the pigs and where's the corn, right? It's not real complex. But the problem primarily, and it leads to this as an industry, what, if anything, can we do? You can take lots of challenges, lots of factors, lots of diseases, but PRRS has been the one that takes our 30 pigs per sow farm, or 31 or 32, and gets whacked. You end up annually for a year at 26. You become this average farm. So we've gotten really good at describing these strains and defining them and knowing everything about. And Dr. Tim Lola for years has said, it's like you keep getting run over by a Mack truck and you've got every single detail possible to describe that truck, including the license plate number, and you just keep getting slammed. You got this great description. And that's really, and this one in the last 12, 14 months in our area has been the prominent strain and one that acts different. So I created this Corpleth map with data from 2017 Census of Ag for number of pigs per county, and another site to find the area of each of these counties, and to look at pig density. Well, it's not real surprising, but where we raise our pigs, where our sow farms are in south central Minnesota, northeast Nebraska, and one in southeast South Dakota. This area, it'll be interesting to see the 22 data from NASS. There are a lot of pigs being moved in there in the last 5 years. That's going to change. So what it forces us to do as a production company is we're building a sow farm down here. 0 is just a number less than 1. There's a couple pigs in that county. But what are the alternatives to protecting the sow herds besides getting them away from this production areas? What's going to be the ramifications going forward? We've got 30-year-old farms. Are we going to put the money back into those here and still break with PRRS? Are we going to put them out here somewhere? Then your challenge is there's very few people there. And you got a 6, 7, 8 hour haul back to feed these pigs is the area where we want to feed them. So this is our system. I created this dot density or kernel density map. This is southwest Minnesota. We're not quite as heavily present there. Our sow farms are right in here. And with the exception of a few down here and 1 there. And then 2 up there, but way too many are right there. You know, we're all, like Chesterton said, we're all in the same boat and we're all seasick on this deal. Because this is where the problem lies. This is, in that mix of dots, are our sow farms. And that becomes the problem. The problem is this. We work hard to eliminate virus when we break a farm. This was one farm from last summer. We closed in January of 20. We have our process of consecutive processing fluids and serum. It gets very intense, very robust. I went over and above on this one. We called it negative in October. We extended out to December. Bred in an on-site GDU, which is separate airspace filtered. Had 330 days closure. About December 14th, I think we said this farm is negative. We open up. 14 days later, we find the 144 virus back in the GDU because we know the neighbor who cooperates with us and tests said, hey, we got this virus in our finisher. So that's the problem we have. We work hard to make negative pigs. The other problem is, even when we make negative pigs, this is my data from an ongoing project, from oral fluids collected every 30 days from negative weaned, non-vaccinated, non-PRRS vaccinated pigs, placed in these locations. And so then we submit the last collection, or if there's clinical signs, we collect it and submit it and stop collecting. So of negative pigs placed in our production region, about 2/3 turn positive somewhere between placement and marketing. So for every sow farm, we've got, 20 wean finish sites, nursery sites, creating these sources of PRRS virus, again, challenging the sow farms that we're trying to protect. So my question is, as industry, that's a challenge, that's a problem with improving our productivity, efficiency in the sow farm. How do we reduce the incidence of PRRS? We work hard on the sow farm level, but is there a way we can reduce this incidence in the nursery grow finish? This is of the sites, we took 14 of them and submitted everyone. 40% of them, almost half of these are positive on the first collection. So my question is, did we really get the virus out from the last group? Is that part of our problem? We're not even getting that virus neutralized and we're infecting the next group and we're calling it aerosol. We're calling it, what is the true incidence of that? And so that's an area that we need to work on if we're going to improve our efficiency. As I mentioned, this model of saying we've got 20, 30 sites from a farm in the multi-site production model. They may be in a county, they may be across 3 states, but in some regard, they're a source of virus again back to the sow farms we're trying to protect. So you can go through this list of factors, and I made this cool word cloud. I mean, PRRS is the one we talk about. Billy Flowers would say that heat stress may be a bigger cost to our systems than PRRS. It's not as dramatic. We've got all these things are challenges, from flu to sow mortality, strep in the pig, labor, you go on and on. But if you want, it's simple. You can budget your cost of production. The one factor that will blow your projected cost of production is a PRRS break. So I'm speaking from a standpoint of a different level than managing that farm day to day. But the reality is we need to understand that if we're going to get better. So challenges in general, sow survivability. And what Jenny mentioned, Steve mentioned, the next speaker, Jason, on prolapse. Sow mortality at 10 to 15% on farms. Certain farms, and prolapses alone, mortality from prolapse at 6%. It's a cost issue, it's a welfare issue, it's a morale issue for asking employees to manage those mortalities. It's a lot of work. So replacement rate, like I mentioned, when you're replacing an extra 10% because of mortality, the rough math says you're kind of negating that whole advantage I talked about on AI for boars. You're feeding lots and lots of gilts to come through and just run this treadmill faster. Nursery growth finish survivability. Again, as was mentioned, it is an association there with colostrum intake. When the Metafarm's second quarter growth finish mortality was 5.15%, I believe, compared to 4.3 from a year ago. There's an issue there. How do I explain to my kids that we lose 25 to 30% of our pigs from birth to market? And we say we're really efficient. We're doing a better job than we were 20 years ago. That's a question we have to ask as industry. PRRS, again, lots of discussions on biocontainment. I believe, and I've been talking to Monsi and others at the U of M, what possible technologies are there to make some headway there to reduce the quantity of virus being expelled or dispersed potentially from these sites. There's others on the list of flu, but to me, if we work down our list and can make progress at least, reduce the incidence, the frequency of breaks, it'll be a huge step to improving our productivity and efficiency. So with that, that's my collection of thoughts and ideas for this topic, and I'd sure be happy to answer any questions you may have.
Questions for Mark?
One time.
Is this working? Okay. You talked about a lot of things that you've got some answers for, or you're finding solutions. What are the areas that you're discussing now in your group that you're starting to collect information to find answers on?
That's a great question. What are we looking at? An area that I've been working on and doing some design trials on is wean age. And again, it's this desire to make this bigger denominator, right? The easiest way to lower your wean pig costs is to wean more pigs. And something's changed. We used to commingle back in the mid-2000s, 6 to 7 to 8 sites, or sow farm flows, various PRRS statuses. And we'd have 1% and 2% nurseries with PRRS positive, PRRS negative, mixed together. You take a PRRS negative flow now, at a 19, 20-day wean, and you're at 2.5%, 3% mortality with nothing, no health challenges, nothing bad going on. I believe as an industry we need to look at wean age and more of a holistic approach. Is birth to market, the time required for the herd techs for treatment and pulls and gruel feeding and all these things we're doing, and look at that as a total picture. Because that to me is, again, we're missing, something's not, we're asking people to do things again, which I don't think we can really continue to ask that question in any labor supply, much less the one we have right now.
Thanks, Mark, for your presentation. Your comment about PERS is right on. The reality, though, is trying to balance it as a manager to say, how do you make sure that it really is PERS and it's a function of what the disease transmission is versus the management susceptibility to it. So my question really is, you're going to have some incident rates, but can you quantify the duration differences of a PERS incident based upon the quality of management? It's been my experience, my better managed farms have less duration of a PERS episode. Interested in your assessment of that.
Yeah, that's a great comment and observation and question. I agree 100%, Steve, is it could become a crutch, right? The data I showed you on the farm weaning 13.1 for the last semester is PERS positive. We had a strain in there, we couldn't find enough to close it and do anything. Get another strain in May, thought it was gonna blow, nothing happened. They just continued to make great pigs, PERS positive. So it can become this crutch, and to me the difference, the interesting, the variation in farm to farm with what is, if there's anything good about the 1441C, it's the same virus infecting multiple nurseries, multiple sow farms, and to see a nursery at 2% mortality that we found 144 in late nursery and didn't know they, except a cough, another one, the same flow of pigs, same age, different site at 10% or 15. And so what else is going on? That's environment, that's co-infections and things out of our control, maybe some in our control. But one of the questions too is, okay, we're gonna get PERS, what do we do, what management, what as management can we do to reduce the time duration of the effect? What I've been doing on the bad ones in the last 2 to 3 years, I think I've done it 3 times now. It's not a fun process, but you eliminate every pregnancy from day 105 down to 90, and you create this massive hole in the farrowing house. You don't deal with those pigs in the nursery. From more of an industry perspective, we're not spreading more virus around. And after that hole, still positive pigs, but they're a different pig. And it's a very difficult process, because I've done it myself a number of times with the staff. When they're done and then over it, they go, you know what, it was still, because we give them a sow mortality of 100 a week, and you stop that process also. But anyway, yeah, how can we reduce the impact of that infection? I don't know all the answers, I'm thinking on that, but.
So maybe just a follow-up then, Mark. Good farms I saw were 6 to 8 week duration. Long farms could be 5 to 6 months.
Right.
And so how do you shorten that duration?
Right.
Because that further decreases the PERS effect.
Right.
I'm done.
The question is, on Steve's data was, you know, several weeks to several months of yeah. And one thing I'll mention is that another debate we have, and I'm on one side, and it's mixed, there's me and there's everybody else. No. There's the on-site GDU concept, right? We bring in this wean gilt. It was great when you close a herd. You do this, you homogenize. But the problem with on-site GDU bringing in a wean gilt for a 5,000 sow, or any size sow farm, 2,500, 3 or 5 or bigger, you're planning horizon for the number of gilts you need, and Jenny said gilts are the fuel of the farm, right? So we're planning how many gilts we need in 7 months from now, and we have this limited space. Then a health event happens, and we lose 200 sows, and we got sows we cull because they never come back in heat. and this is our gilt supply. Some of that difference is the fact I'm locked into having, and my on-site gilts got sick because they got furs. The other model, we have other farms where we raise them off-site somewhere up in central Minnesota where they're going to stay clean. Bring them down at 180 days. The truck ride spurs the heat. And if we need more gilts in 3 weeks from now, we can turn our quarantine room in 3 weeks instead of 4, or bring in 70 instead of 50 or whatever. Some of that drag is the effect of getting smacked on your GDU source on these on-site GDUs. So there's advantages to them and disadvantages to them.
Hi, Mark. One great presentation. So one, as always, right? That's why Bob Morrison would call you the most scientific producer. Going back to your open crates design today, based on your experience, what would be your recommendation? Is that for healthy herds, or can you also implement that in endemic herds for PRRS, Michael?
Yeah, great question. I don't know on Myco. Myco-negative herd. PRRS, this same farm, unfortunately, when it was closed, we became negative with that protocol I showed you. We used that open system right through the closure. And so it's like the anti-mech rebel type of deal. Right now, that's a positive farm. It's a positive farm, and like I say, the weaning excellent numbers. We're planning to stay in this system, and we're closed now again for the 144 we got last year. So it was handy to use that same method in the heart of the clinical PRRS. When the sows are drying up and the pigs are dying, you're not making a decision about a sow and a litter. You just keep putting pigs into rooms, and the sow dries up, you take her out, she takes on these pigs. And so that made that much easier, actually, in that ugly acute phase. First time we tried that, and the farm staff really preferred that over the other way.
Mark, I appreciate your comments about biocontainment, and we're usually worried about bringing the disease in, but not as much about where else we're spreading it. And do you have some thoughts in terms of ways that we can improve the biocontainment, or things you think might work there?
So I have this vision. I've mentioned it to Monsi, and I've mentioned internally in our group, and they kind of look at me like, So I'll take the example of our 5,000 sow home farm is 0.52 miles from a 6,000 head finisher. They're great neighbors. They put negative pigs in there. They test them every 2 weeks. They've moved them, depopulated that site in a matter of a weekend. But you got 6,000 pigs spewing out virus in some manner, half mile away to the southeast, which makes it worse, I believe. My surveillance project would say that we're missing a lot of these positives with 3 ropes or 6 ropes. So how early was it positive before we found it? But my analogy is if we could do something to make that the equivalent of taking that 6,000 pigs half mile away to like 1,000 pigs 3 miles away, there's only like 16 or 20 fans probably on that site, right? Your curtains aren't down in your high-risk time of year. Could you find some sort of a mechanism just to at least engulf that air, to let it pull through, not talking a filtering system of some sort, but a knocking down the quantity? And it's just the first thought of burlap sacks or something,
So let's say thank you, Mark, for your comments and questions and presentation.